This whole unit is going to be about triangles, but with our triangles, we're going to talk about angle measures quite a bit. So I'd also like to do some warm-ups with this so we can remind ourselves about our angles. If I look at numbers 1, 2, and 3, and if I were asked to classify them as acute, obtuse, or right, if I started with angle 1, anytime I see this box symbol, we need to remember that that's a 90-degree angle, which means it's a right angle. Anything less than 90 is an acute angle, and anything greater than 90 but less than 180 is an obtuse angle. So this next problem will also use similar steps in this unit, in this section especially. It says if the perimeter is 47, find x and the lengths of the three sides. So I need to know what perimeter means. Perimeter is the distance around the outside, or all the sides added up. So if we added these three together and set equal to 47, you may want to try this on a piece of scratch paper. If I combined my like terms, 3x plus 2x plus x is 6x, plus 8 plus 6 plus 3 is 17. So if I subtract 17 from both sides, I get 6x equals 30. So x is 5. If I go back and I plug x in for these measures to find the lengths, I have a side measure that's 8, I have a side measure that's 16, and another side measure that's 23. So today's objectives will be to classify triangles by their angle measures and side lengths, as well as using their classifications to find angle measures and side lengths. So here's our vocab. We're going to talk about acute triangles, equiangular, right, obtuse triangles, as well as equilateral, isosceles, and scalene. So a lot of this should be review, but we need to start somewhere, so we'll start with reviewing basics of triangles. Remember that a triangle has three sides and can be classified by both angles or sides. So if we look in this picture, if I wanted you to pick out the pieces of a triangle, know that we have sides. Well, notice that if it starts at A and ends at C, the sides are created by segments. So we have side AB, side BC, and side AC. Just like in our first unit, when we name a segment, we want to put the little bar over the top. We also have corners. Those are called vertices. So we need to know the vertices are the points A, B, and C. So now we're going to work on triangle classifications by angle measures. So if all three angles in a triangle are acute, we call it an acute triangle. So three acute angles. We also have equiangular, which is also acute. But if those three acute angles are all the same, then we call it equiangular. Notice if they're the same, they have equal measures, or the angles are congruent. So they would have the little symbols on here. If you were thinking about, okay, then if they're always the same, the sum of the angles in a triangle are 180. If you divide by 3, the equiangular triangles angles will always be 60 degrees. Now I can have a right triangle if there is one right angle in a triangle. I can also have an obtuse triangle if there's one obtuse angle. So now we're going to look at some examples. In this picture, we need to read the directions because I see numerous triangles in the picture, and it says to classify B, D, C. So we don't want the whole thing, we kind of want to cut this part out, and we want to do B, D, C. So D, notice, is not a 90-degree angle in this picture because we're using this side. So we'd say 90 minus 20, so D is actually 70. This one's 10, but I see that angle B is 100 degrees. So angle B is an obtuse angle. So that triangle must be an obtuse triangle. Okay, what if I switch, same picture, but I'm looking at A, B, D, and I see that ABD, this angle right here, and CBD, the one that's 100, form a linear pair, so they're supplementary, which means that if this one's 100 and they make a straight line, this one has to be 80. So we've got ABD is 80, we've got A, it says is 80, and 20. So those are all acute angles, so that would be an acute triangle. In this picture, if I said FHG, well, notice I have 60, 60, well, 180 minus 60, or 90 minus 30 says this is also 60. So, this one is acute, but it's also equiangular. If you have an equiangular, don't say acute, be more specific. This is the more specific classification, so go ahead and use equiangular rather than acute, even though it's both. Now we're going to look at classifications by side lengths. Just like we had equiangular, where all the angles were equal, we can also have all the sides being equal, and that would be called equilateral. Remember, with segments, to show congruence, we use our little dashes. So that shows all the sides are the same. Well, if we only have two congruent sides, that's called isosceles. So you'd see two sides with dashes that match. And then we also have, what if no sides were congruent? That would be scalene. So there's some definitions that you're really just going to have to memorize so that we know them. Also, remember, when you look at a figure, you cannot assume segments are congruent based on appearance. You need to look at the markings. So just because they look like they're the same does not mean that they're the same. If the numbers don't match and there's no symbol, we don't want to ever assume anything. So in this picture, we are asked to classify EHF, the smaller one, by its side lengths. Well, I see in the picture that HF and EF have congruent marks, so we know those are the same. So if EF is 10, HF is also 10. So we have 10, 10, and 12, meaning two sides are the same, so we'd call that isosceles. Same picture, now we're going to look at the big one, EHG. Notice on this one we've got 12, we've got 11, but from G to E, we actually passed two segments. We went 4 and we went 10, so EG is actually 14. So 12, 11, and 14 are all different, so we're going to call that scalene. New picture, ACD, this triangle, if we connect AC and D, I've got 5, I've got 8, and I only have one dash, which says it's the same as BC, or AB is the same as AC. So I've got 15, 5, and 18, all different, so that triangle is scalene. Now we're going to go backwards. Instead of just classifying, we're going to use the information to find some missing pieces of the triangle. This first says to find, well, it says find the side lengths of this picture, so very similar to the warm-up question, but we got to use properties as well. So the first thing we want to do is find the value of x. I actually have 3 pieces in this picture that have x's, but we need to make sure we pick the 2 that are related. So if I see KL and KJ both have dashes, that means that they're congruent. Those 2 are related. JL is not. So in the picture, it's given to us that JK is congruent to KL, which means their measures are equal, because that's what it means to be congruent. So we can substitute their measures into that equation. Since I have, normally we start with getting rid of the x's first, or I can add 10.7 to both sides. So if plus negative 10.7 plus 10.7 goes away. But when I add it to this side, I get 17. If I subtract 2x from both sides, kind of do those together real quick, I get 2x, divide both sides by 2, and we get that x is 8.5. But notice in the picture, it said to find the side lengths. So did it say just to find x? Not quite. So we have another step where we need to plug that in. So since x is 8.5, we're going to plug that measure in to the side lengths. So if I start with JK, I plug in 8.5 for x, and I simplify, I'll get that JK's measure is 23.3, which means I know that KL should be the same, but sometimes it's helpful to plug in as well, just to make sure they come out the same to see if we solved correctly. So I'll plug 8 in, or x in again, put 8.5 in for x, solve, and I should get that those 2 measures are the same because the picture told us they were congruent. And then I plug into the last one. I plug 8.5 in for x, solve, and then I get 44.5. So those are the three measures of our triangle. We're going to do one more like that. It says find the side lengths of the equilateral. Well, it's given to us that all three measures are the same because it says it's equilateral. So if it's given that they're all congruent, because that's what it means to be equilateral, that also means that the measures are equal, because that's what congruent means. So we can say, well, the measures are equal. And now if I just pick two, you could pick any of the two, but we'll pick FG and GH, and I plug those measures in. We're going to say 3y minus 4 equals 2y plus 3. So I'll subtract 2y from both sides, and then I'll add 4 to both sides, and I get that y is 7. Once again, it doesn't say just to solve for x, it says to find the side lengths. So I found the missing piece. Now we're going to take 7, and we're going to plug it in to our measures. So if I plug in for FG, I'm going to say 3 now times 7 minus 4 is 17, which really means that all the other measures should also be 17. But we can, just to check, plug 7 in for the y's on the other measures, and we should see that algebraically, yes, they are all 17. Okay, now we're going to finish up with just one application problem. This problem says a steel mill produces roof supports by welding pieces of steel beams into equilateral triangles. So first of all, we need to remember equilateral means equal sides. Each side of the triangle is 18 feet long, and we want to know how many triangles can be formed from 420 feet of steel beam. Okay, so first of all, we may want to think about how much steel do we need to make one roof support. So if they're all equilateral triangles and each side is 18 feet long, we want to think about the perimeter of the equilateral triangle. How much does it make to go around the outside? And that'll help us see how much steel do we need for one support. So for perimeter, we're going to add up the sides. Well, it's a triangle, so there's 3 sides. And if it's equilateral, it means they're all the same. So the perimeter we could find by saying 3 times 18. So the perimeter of one triangle, or the amount of steel needed for one roof support, is 54 feet. So now, if it takes 54 feet to make one beam, if I decide to divide the amount of steel I have by how much it takes to make one beam, so I'd say 420 divided by 54, I'd get 7 7/9. So I know I can make 7 roof supports, but with this 7/9 that's left of steel, notice that doesn't quite make another support. So I only have enough steel to make 7 triangles, or 7 supports, with the 420 pieces of steel. So my answer would be 7. I kind of just knock off the extra because I can't make a whole beam or a whole support. Thank you for listening. When you get to class, we will work on using these classifications a little bit more, and I'll see you soon.